Hey guys, welcome back to CyberPlatter. So this is a full course on Microsoft Sentinel. In this next chapter, we will discuss threat hunting in Microsoft Sentinel. What is threat hunting? How is it different from analytic rules? We will learn KQL and also how to use hunting queries for threat hunting. So before we start, if you've missed any previous chapters, you can find the links and the full playlist in the description below. In this chapter, we will cover the basics and the foundation for KQL that is required for threat hunting. But if you want to know KQL in depth, there is another video which I will link it in the description box. So what is threat hunting, right? First is threat hunting is a proactive cybersecurity approach. In threat hunting, security analysts manually search for hidden threats that automated security tools may have missed. So instead of relying on alerts and incidents, analysts use hypotheses, past data that is historical data, and advanced queries to uncover hidden threats. In Microsoft Sentinel, threat hunting is done using Kusto Query Language, that is KQL, in the hunting blade. So let me go to the portal, select Microsoft Sentinel here, and then go to the workspace. And then here under threat management, if I select hunting, this is where we usually do threat hunting. And this enables analysts to analyze logs, spot anomalies, and investigate suspicious activity proactively. And if I scroll down here in configuration, there is analytics. This is the analytic rules. This, on the other hand, we discussed already that these are automated detection mechanisms that generate alerts when predefined conditions are met. So these rules continuously monitor logs and telemetry data to detect known threats or suspicious patterns. Now let's look at the difference between threat hunting and analytic rules. So threat hunting is a proactive approach, whereas analytic rules is a reactive approach. Execution method in threat hunting is manual, and in analytics rule it is automated. The objective of threat hunting is to find unknown threats, and analytic rules is to detect known threats. In threat hunting, it is interactive investigation, and analytic rules is based on predefined detection logic. The use case for threat hunting is mainly to search for hidden attack patterns, and analytic rules is continuously monitor for threats. The tool used for threat hunting is hunting queries, and for analytic rules are the rules that we defined previously in the other chapters like scheduled queries or near real-time queries. So for threat hunting or for analytic rules, KQL is the foundation. So let's see what is KQL and the basics of KQL. All of us know that KQL stands for Kusto Query Language. It is a read-only query language. So what is a read-only query language? Read-only query language is a type of query language that allows users to retrieve and analyze data. It does not allow to modify, update, or delete the data, okay? So that's why it is called read-only query language. It's mainly used for data exploration, reporting, and analysis. So you can use KQL to write queries in Azure Data Explorer, Azure Monitor, Log Analytics, Microsoft Sentinel, and other Azure services. KQL follows a structured format for writing queries, so it makes it easier to read and understand. So now we will go to General and then under that Logs and try to write some KQL queries, understand KQL basics using security events table. So first let me switch from simple mode to KQL mode. Minimize this. So first in any KQL query is the table name. So table name represents the data source, that is a table from which you are querying data. For example, security event. So as soon as I start writing, right, you can see that the query language starts giving me options, and it also has tab completion. I'll select security event. There are many other tables actually, like sign-in logs, device network events, audit logs. So security event table is a built-in log table in Microsoft Sentinel and Azure Monitor, and it stores Windows security event logs collected from the connected machines. So if you remember, in one of the previous chapters, we connected a Windows machine VM to Microsoft Sentinel. So we will look at the data from that machine. So you can remove this pipe. First, the table name, you can just run the table name and see if it has data. So it does have data. And this is the time range. You can change the time range from here as well, 30 minutes, 4 hours, 7 days, or custom date also. And then if I use this pipe operator, right, this is used to chain commands together. That is passing the output of one operation as an input to the next. So we will pass the output of security event table as an input to the next one, where we will say count. And also here, if you click on this arrow, you can see what the count operator does. It says it returns the number of records in the input record set, and it also gives you the syntax and how to use it. So for now, we are using pipe operator to get the output of security event table and send that as an input to count. So each command processes data and then passes it to the next command using the pipe operator. So if I run this now, so it says that these are the number of rows, and count is an operator that simply returns the total number of rows or events in the security event table or any other table. And then the next operator is take. So take is used to retrieve a random subset of rows from a table. So it is useful for quickly previewing data without running expensive queries on large data sets. So I can say take 5. So it will return random 5 rows. As you can see here, these are random. Next time you run, you might get different result. And instead of take, you can also use limit. This does exactly the same thing. And take and a limit can be used interchangeably. So if I say 5, it will randomly return 5 random rows. So limit is just an alias for take, so you can use either. With take and limit, it is random rows that are retrieved, but with sort is another operator. You can order results based on one or more columns. You can say sort by time generated, one of the columns in security event, like you can see here, and then run this. The default sort order is descending, but if you want it in ascending order, you can say ASE and then run it. So ascending is from smallest to largest or oldest to newest for time. In descending, it is from largest to smallest, that is newest to oldest for time. So if I use ASE, I will get the oldest time first. You see this? It is March 20th. If I just remove this or write descending and then run it, it will be March 23rd, that is the newest data first. Similar to sort by, you can also use order by. It's going to do the same. So if you scroll down here, it exactly tells you what is the syntax and how you can use it, what is ascending, what is descending, where should you provide the column name, all the details. So if I run this, it's going to fetch me the same result as sort by. Next operator is project. This is used to select only specific columns from a table. So it helps reduce unnecessary data and improve query efficiency. So I can say project and it will start giving me the column names here. I can say project account, comma, then time generated, comma, and then I can say event ID and then run. So if you see, you will get only these 3 columns projectors for that. And if you don't want the default column names, you can also change it. Like for example, I can say project user is equal to account, time is equal to time generated, and ID is equal to event ID. So you see, this is showing, the previous result was showing us the default column names, account, time generated, event ID. Now I will run this. So it changes to the user, time and ID name. So you can use project to rename columns as well. And you can also use project to create a new column based on a calculated value. Let me remove all of this and project only event data and then run. So this is the event ID data, and then I'll say event category is equal to toString. ToString, like you can see, converts input to a string value. It is a data type conversion function. So it converts a value into a string, that is text format. And then I will say event ID multiplied by 10. If I run this, so this is something random that I'm trying to explain. So you have the event ID and then you created a new column called event category, and then in that you're storing event ID multiplied by 10. So this is how you can do it. So we got the event category, and event category we're storing it as a text because you're using toString data type here. And the next operator that we'll see is distinct. So distinct is used to remove duplicate values from a column or a combination of columns. So it returns only unique records from a data set. So right now you see event ID, there are duplicate numbers 4625, 4625, it goes on. So if I want to get only the unique values from it, I can say distinct event ID and then run. You will get only the distinct values in that column. Next operator is where. So this is used to filter data based on specific conditions. It works like the where clause in SQL, allowing you to retrieve only relevant rows. Like for example, I will say where security event pipette to where event ID is equal to 4625. If I run this, so this will filter events where event ID is 4625, that is, it is representing failed login attempts. You can also, combine multiple conditions using and or operator. Like for example, if I say event ID is equal to 4625 and account is equal to admin, and then if I run, there are no results. But if I change, so if I'm using equal to, it will exactly check for the same thing, but I can say contains and then run. We can still see results because it's not just admin, it is administrator or capital admin. So you can use multiple conditions using security event using and or operator. So if you're using and, you're getting columns that event ID is equal to 4625 and also the account contains admin. If I do or, it is either one of them. And you can also use where condition to filter by time range. Like for example, where time generated is more than 24 hours. So you can use it to filter by time range as well. Also something that I wanted to mention, suppose say if I'm using account contains admin. This filters events where account column contains the word admin anywhere, like what we saw before, that it can contain anywhere, administrator, somewhere, Windows log demo and then administrator. But if I use has and run it again, it matches whole words only, not the others. Like it is getting only admin, right? Not the other things. But if I say equal to and then run it, I will not get any results because with has, it was in capitals and I am writing admin small. So top is the next operator. It is used to return the highest or lowest n records based on a specified column. So if I say top 4 by account and then run it, so it is returning the number of rows to return is 4 and account is the column to sort by, and default is descending, that is largest values first. So you see it started W, Y. So if I say top 10 by time generated and then enter, this is going to retrieve the top 10 latest security events that are sorted by time generated. You can also get the oldest by using ascend operator. So with sort, it was sorting it, but it was returning all rows without limiting results. But in top, it returns only the top n rows based on sorting. Next operator is summarize. So this is used for aggregation, that is allowing you to group data and apply functions like count, sum, average, and so on. It works similarly to group by in SQL. So here if I scroll down, it is giving you the syntax. It says summarize, then the summarize parameter, and then aggregation, a call to an aggregation function such as count or average. So let's try this summarize. Then I will say count and then run, and this will give you the total number of events in security event. So we are here counting the number of security events. You can also store this in another column, same total events is equal to count, and then it stores that in a column called total events. And then you can also use summarize event count is equal to count by event ID and then run. So this counts the number of occurrences for each event ID. So before we did it for the entire table, now we are doing it for each event ID. And if you want, say, only failed login count, you can do that as well. So I'm going to remove this, say where event ID is equal to event ID is equal to 4625, that is to filter only failed login attempts. Then again we will pipe it and send it to summarize. Summarize failed login count is equal to count by account. Let me run this. So this counts failed login attempts for each account. So all of these accounts failed login attempts is going on. So mine is a test VM, so it doesn't matter. I usually keep it closed. So that is how you see the failed login attempts, the number. And you can do the same thing using event ID 4624 to get the successful logins. And then we will summarize saying last login time is equal to max time generated by account. And this finds the most recent, that is maximum login time for each user. If I run this, so you can see that the most recent login time for each user. And you can also use summarize to group by multiple columns. So let me remove this and then summarize event count is equal to count by event ID, comma account. So if I run this groups by both event ID and account, showing the number of events per user. like this. Now that we know some basics of KQL, let's go back to Microsoft Sentinel, the home page. Let's close this. Okay. And under threat management, let's go to hunting. And there you can create a new hunt. Give the hunt name, description, owner. You can select the status and then hypothesis. Is it validated, invalidated, known? We'll do this in a minute. But first, let's go to queries. It also says the hunting query is moved under Content Hub. So you see there are few hunting queries because we have connected Windows machine to this. So if I go to Content Management and Content Hub, let me close this. And here content type, I'm gonna select only hunting query and then say apply. And status, I'm gonna select only installed and then apply. It gives me Windows security events. So here you can see there are many solutions installed under this. If I scroll to the right, it says content type hunting query is also included. So there are many of these. Let's take one for example, least common processes by command line. So either I can run query or view results. So this is the query that is getting executed here. And it says it looks across your environment for least common process command lines, may be noisy and require allow listing. And if I scroll down, it also tells you the tactic is execution. And then let's go and run this query. Click run query. When I run query, notice that the results go from 0, right? So there are 0 results, but still we will go ahead and view results here. So no results for the specified time range. I will go to KQL mode. So this is the hunting query. So let's try to understand what it is doing here. So this query analyzes process creation events 4688 from security event logs, and it filters suspicious executions while ignoring allowed processes. And then it summarizes occurrences and applies sensitivity thresholds to detect anomalies. So the let operator here will define the variables. So these are the variables that are getting defined. First is the start time and then there is end time. Both of them together, they define the search time range. So you can see that, let me actually zoom this more. So this toDateTime is a data type conversion function that converts a value into a date time format. Okay, so we are taking the start time, end time. This is to define the search time range. And then we are saying look back is equal to start time minus. So if you hover over it, it tells you what this is. So subtract and then 7D. That is 7 days. So it expands the search to 7 days before the start time. And then we are saying allow list. This is a list of known safe processes. So we are defining that as well. These are the safe processes. And then the sensitivity, this is a threshold. The default is 5 to filter out frequent events. Next, we are querying the security event table, where time generated between lookup to end time, that is, it keeps the logs within the defined time range. And then it says event ID is equal to 4688, that is, it focuses on process creation events. And then new process name does not end with, this is for do not, the exclamatory mark ends with conhost.exe. So it ignores anything with conhost.exe. This is often a legitimate Windows process. And then we are using the extend operator. Extend operator is used to create new calculated columns or modify existing ones by adding computed values to a data set. So it does not remove any existing columns, but it will simply append the new ones for analysis. Let me open a new query. So if I say security event, pipe it, extend event time is equal to date time and then time generated. Then if I run this, this will create a new column called event time, like you can see here, with date time format. So you can use extend operator to create new calculated columns or modify the existing ones. Let's go back to our query here. So you're using extend and creating all these new columns. This extracts the actual process name from a full path. Okay. So what we are trying to do, so if there is a full path like this, we are trying to extract only cmd.exe. Okay. Let's go back here. This split, so it splits the path into an array by using this operator \. Then array length, this counts the folder depth, and this is proc array, and then we are creating another column where we are storing this value in it -1, that is proc array length. And then the proc is proc array and the last index, which selects the last item, the actual executable name. And then we are using where to filter, and this excludes known safe executables. This is the variable we defined here, allow list, where we gave the safe execution names, and that will be removed here. And then we are using summarize to aggregate suspicious commands and collect relevant metadata. So it is getting us start time, that is the first time that the command appeared, and the last time the command appeared. And then this count will give you the number of times this command was executed. And then we are using decount computer, that will give you the number of unique computers affected, that is distinct count. And then make set computer max size is equal to 500. This stores up to 500 affected computers. The hosts, we are storing up to 500 affected computers. Then we are calculating the number of unique users who executed it, that is decount subject username, that is distinct count. And then again we are storing up to 500 user accounts using make set. And also again we are filtering it using where command and using sensitivity. So this will only keep low frequency events. So if a command appears too frequently, it's likely a normal process. That's the concept. And then we are extending it, that is it adds a timestamp column, start time UTC, for easier analysis. So in summary, what this entire hunting query is doing, it is detecting rare processes executions over a 7-day look back period. So we provided this, and then it ignores safe or known processes using this allow list. And then we are using extract to get the process names from full file paths. And then it groups executions by command line arguments to find unique attacks. So we are using this. Then it counts affected hosts and users while filtering out the frequent events. So this is how this hunting query works. I just wanted to show you this and explain how hunting queries are written. It's usually huge queries that you write. So you have to get used to KQL to understand the hunting queries. Now let me close this and then go to hunting under threat management and create a new hunt. And this hunting, we will do it for Entra ID, audit logs. I will use the same description and then select an owner, and the status is new as of now, and the hypothesis is unknown because we haven't validated or invalidated it. You'll have to run it to see if it is validated or invalidated. So I'm going to say unknown and then create. So it created the new hunt. Let me go to this hunt. So again, you can select the time here, last 24 hours, 48 hours, whatever the custom range that you want. Then there is query action. Either you can create a new query or add queries to your hunt. So for now, we will select query actions, new query. And the name for this, we will use the same example like before, new user creation. And the query is audit logs, where operation name is equal to add user. So that's the query. If I scroll down, tactics and techniques, you can also add entity mapping, which I'm not going to do here because we're keeping it simple. You'll have to select the tactics and techniques here. I'm going to select initial access and persistence and then create. So our new query is created, new user creation. And then let's create another hunting query. This is for user deletion. And the query would be audit logs, where operation name is equal to delete user. And then scroll down, tactics and techniques. So this is deletion, so it is related to evasion of techniques. I will say evasion masquerading and then create. Now we will try creating and deleting a user ID. Let's go to Entra ID and then add user, create new user, test user 4, and I will give the same display name and then review and create. Okay, successfully created user. And then if I go to manage and then users, I will delete the test user 1. So delete, select it and say delete the selected user. Yes, user successfully deleted. And then now let's go back to our Sentinel. Let's show this panel, and then here we will do run selected. Okay, we'll select both and say run selected queries. You can see that new user creation, the result is 1. It might take a little bit more time for the other one to pop up. So let's get back to that later. But if I click on this new user creation, you can also see that the result is 1, and you can click the result to see what exactly happened. And here it says add user, operation name, new user was added. Let's go back to the hunt. Refresh it again. Let's see if the deletion comes up. And if you also see here, right, it says initial access, the tactics that we selected previously, it shows up here. We selected initial access and persistence. It is coming up. So it's still taking time, but results should be appearing here, where user deletion there is 1 and new user creation. We already saw new user creation. It's taking time for it to load. And then once you have validated the results, you can come here, say actions, and you can create an incident for this or add new queries to hunt. So you can create an incident, click create incident, and it will create the title, description. It's getting it from the previous hunt page. Severity medium, you can change it. Status is new, and you can assign the owner, and then go to bookmarks. If there are any bookmarks to your incident, we already talked about bookmarks. You can add them here. So you can say add bookmarks and then search for your bookmark and add them here, and then create new. So successfully created an incident. And then if I open this panel, I can also say status is closed, because we already did validate this, and also we validated the queries. So I can select validated and then say apply for the hypothesis. And then if I go back to Microsoft Sentinel under incidents, our new incident, that is Entra ID audit logs, is created. And also if you notice, new user creation is also created because we created NRT rules and also a schedule rule which will run every 5 hours. For that as well, an incident is created because we created a new user. So if I go to Entra ID audit logs and say view full details, and then go to activity log, it says incident was created And then because of the automation rules that we have set up before, incident status was changed to active by the automation rule, and then the severity was changed to high, and then it was assigned to an owner, and also a tag was created saying automation rule. Let me close this, go back to our hunting. And the other options here, you can delete this hunting if you don't want this. And then you can add your comments to this as well. I will close this. So that's it about threat hunting, guys. I hope this video was helpful. If so, please don't forget to like, subscribe and share our videos. I will see you in another video on Microsoft Sentinel soon. Until then, take care. Bye bye.